So the last thing we're going to look at for this week is logarithmic functions. That's both 5.4 part 1 and 5.5. And we're going to do all the kinds of things we normally do when we look at a function. We'll define it, what it looks like when you graph it, and we'll look at how can you solve equations with logarithms. So when we had problems in the last section with like population or exponential growth or decay, where was the variable all the time? It was always in the exponent. And depending on your problem, having a variable in the exponent can be hard to solve. That one is not hard to solve because you can find a nice number that you can raise 2 to a power and get 16. What power could you raise 2 to? The 4th power. Okay, so that one's okay because you get a nice answer. But if I just change it a little bit, well, now it's not such a nice answer. Okay, 2 to the 3rd power is 8. That's too small. 2 to the 4th power is 16. That's too big. So the answer is between 3 and 4. Well, what is it exactly? That's what a logarithm will tell you how to find. Right, so logarithms are used to solve equations that have variables in the exponent. That's what they do. So that's the connection with exponentials. Exponentials have variables in the exponent, and logarithms can solve those kinds of problems. So a log function is exactly the opposite. It's the inverse of exponential. Okay, what does inverse mean? It just means it's the opposite. So like if you want to think of the inverse operation of addition, it's subtraction. The inverse operation of multiplication, division. What's the inverse operation of squaring? Square rooting, right? They're opposites. They kind of cancel each other out. And that's exactly what log functions and exponential functions do. They cancel each other out. They're opposites. And anytime that you graph inverse functions, they look special. They are mirror images of each other. Inverse functions are always mirror images, specifically over the line y equals x. Let me show you for squaring and square rooting. Okay, so let's graph square root of x, and let's graph x squared. Those are inverses. Man, let's just look at quadrant. Let's go 0 to 10, 0 to 10. Okay, there's your square root. There's your square. And if I put in the line y equals x, you're going to notice it cuts them like perfectly on the diagonal. So if you were to fold, like if this was a piece of paper and you folded it right on that black line, the red graph would land right on top of the blue line. That's what inverse functions look like. They're reflections of each other. Now, that's not an exponential and a log function. That's a square and a square root function. But it's the same idea. And I'll show you what a log function looks like in a little bit. All right, actually, I already have it right here. So, one thing that the calculator has trouble with is drawing log functions because they get very steep, like towards the origin in this case. When a line gets really, really steep, the calculator can have trouble drawing it. So that's what the calculator would show you if you typed in a log function. What it really should look like is this. It should look like that. So in red, that's a log function. In blue, that's an exponential. That's what we did yesterday. They curve up really fast. Can everyone see how they are reflections of each other over that diagonal? Like if you folded it, it'd land right on top of it. So we know exponential functions go up extremely fast, while logarithms go up extremely slow.
Sorry. No, don't actually.
So if you type, that's all right. If you type in something like log, and let's type in 100. If you plug in an x value of 100, you get a y value of 2. So by the time you go 100 units out on the x-axis, you've only gone up 2. If you go out 10,000 units on the x-axis, so go all the way over to 10,000, you've only gone up 4. So think about how slow that is. You go 10,000 units to the right, and you go 4 units up. That's a very, very slow upward climb. Very slow. And it almost looks like it flattens out, but logarithms do not flatten out. There are no horizontal asymptotes with logarithms. When we studied exponentials, what kind of asymptote did that blue graph have?
Vertical.
So a vertical asymptote would mean then the domain is not all real numbers.
Horizontal.
Right. So exponential functions had a horizontal asymptote. Logs and exponentials, everything switches. So if exponential functions had a horizontal asymptote, what kind of asymptote do you think logarithms have?
Vertical.
They do. They have a vertical, in this case, right there. So exponentials had a horizontal, logarithms have a vertical. It's like everything switches from exponentials to logs. Okay, that red dotted line does not apply to the blue graph, it just applies to the red one. All right, so how do you write a logarithm? Well, first thing is, like, if you had a piece of lined paper, this is what it would look like. Let me fix that. The y, the equals, the log, and the x would be right on the line. The a is what we call a subscript. It would be below the line. There are no exponents written up there at all right now. There's no exponents. If I did this, that's an exponent now. Okay, 2. So an example would be something like y equals, and I'm going to tell you how to say this in a minute. That's something you could type in on your calculator and you could get an answer, if you know how to type it in. Okay, and you read it left to right, and it's read y equals, that's the part you start with, log, and since the a is lower, we call a the base. Log base a of x. So the red one, you would read y equals log base 4 of 5. And what the base is, the base, like being a 4, it just controls the kind of logarithm that you're doing. It's kind of like when you have roots and you put an index outside the root. The index controls what kind of root you're doing. So like if I put a 3, what kind of root is that? Cube. That's a cube root. If I put a 5, what kind of root is that? It's a 5th root. If I put a 4 here, that's a log, and we're doing it with a base of 4. Okay? So it's just like doing a 4th root versus a cube root. Just it's a little bit different, but it's still the same. It's the same idea, just a different base on the log. Okay, this right here, that's called the argument. Okay, the argument is the thing that you're taking the log of. So in the red one, what would be my argument? 5. So 5 is what I'm taking the log of, and base 4 is the type of log I'm doing. It's the type of log that I'm going to do. Okay, so 4 is called the base, 5 is called the argument. How would you read this one?
Y equals log base 3 of 12.
Yep, log base 3 of 12. So 12 is what you're taking the log of, and base 3 is the type of log that you're going to do to the 12. Now, if the base is a 10, there's a special name for that kind of log. There are two logs with special bases. One of them is base 10, and that is called the common log. So if I gave you a question and just said, find the common log of 7. When I say find the common log, I'm assuming the base is a 10. That's what I want you to do, base 10. And the calculator has a button for doing common logs. So on your calculator, you turn it on, and you press log, and you put a 7. That is common log. You might be like, well, wait, there's no base there. Well,
Why did you put log?
that's okay. If you don't see a base written, it's always assumed to be the common log. So you could write this, and somebody would know, okay, they want the common log. Or you could write it this way. Nobody writes it the second way. If you want common log, you can just leave the base off. Again, the log button, it's on the left-hand side, right by the 7. Okay, so any question on what the common log is? It's a base 10. And it's one of two logs that the calculator can do by pressing a single button. So calculators can do common logs. And there's one other kind of log that a calculator can do. And I'm going to show you that one. It's near the log button. It's right below it. Yeah, it's actually a capital L. Yeah, if you press it, it's a capital L and a capital N. All the buttons, I think, use capital letters for printing, but then when you put it in on the screen, it actually comes up lowercase. I usually write it lowercase. So the other special log is called a natural log. That's where the LN abbreviation comes from that you saw. Why isn't it NL instead of LN? I don't know. This log is the only other log that has a special name. So common log is base 10. Natural log is when the base is E. And we talked a little about that in the homework. Does anybody remember what E is about?
2.7128.
It's about 2.718. And then if you type it in, it says 1828, 1828. It doesn't keep repeating 1828. E button is second divided by, and then you can see what E is. So if the base is E, that is called a natural log. Now, just like you'll never see this. You'll never see log base 10 written. If it's a base 10, they're going to leave the 10 off. Well, you're never going to see that either. These two logs are used a lot, so that's why they have abbreviations for them. The abbreviation for base 10 is just leave the 10 off. The abbreviation when you have a base E is a lowercase l, lowercase n. So writing a lowercase l, lowercase n is exactly the same thing as writing log base E. So on the test and in the homework, you'll never see log base E written. What you have to remember, though, is if you see like a problem that says to find the ln of 12, there is a base on that ln, but it's hidden. You have to remember that the base is e. Right, so if you see a natural log, ln, what's the base that's hidden? E. Okay, it's e. And if you just see the word log, and you don't see a base at all, what base is hidden there? 10. It's a 10. And other than that, if it's not a 10 or it's not an e, they have to write down what the base is. Okay, like log base 3 of 16. If you want to write that, there's no other way to write that. You have to put the 3 and you have to put the 16. Okay, so common log, that's a base of 10. Natural log is a base of e. So instead of seeing something like this, you're going to see what's on the right. Here's an example with numbers. Log base e of 14, not something that you're going to see. You're going to see the ln of 14. Question on that? Yeah.
So after you type in log on the calculator, the next thing's going to be the base.
So we're not going to learn how to do, because some calculators don't have the capability to do a base. Like if you have a calculator like this one, well, like a scientific one, it doesn't have a button to change the base. So I'm going to show you eventually how to do it without typing in a base. There's a trick you can do. Like you can type this in on the calculator, any calculator. Log base 3 of 11. There is no button for log base 3, but there's a trick you can do to type it in.
So something like subscripts or something?
Nope, not even subscripts. You just even like a basic calculator from like 30 years ago can do it. No, nothing fancy at all. So I'm gonna show you that trick, but not today. So for now, the only two logs you're going to know how to do are pressing the log button, which will do base 10, and then pressing the ln button, which will do base e. Can you do other bases? Absolutely. But I'm not going to show you how today.
If you go to second math, I don't know if it's just mine, second math has it. Log base.
It does?
Yeah. I don't know if it's just on mine. If you go second
Second?
math, and then
That won't work on mine.
It's crossed out.
oh wait, not second math, just math. It's
It's crossed out on this one.
If you keep going, keep pressing the button to go down.
Yeah.
Oh, yours doesn't have it.
Yeah.
I have it on mine.
Is it crossed out?
Well, like
Oh wait, it's right there. Log
It's right there,
base.
log base.
Yeah.
It's crossed out.
But it's crossed out.
What do you mean?
Oh, no, on mine it's crossed out.
Oh, if you
See? Yeah. Yeah.
That makes sense.
So I'm going to show you how to do it.
I was so confused.
Okay, so let's think a little bit about the domain and range. When we had an exponential, what was the domain of exponentials?
All numbers.
The domain was all real numbers. But in logarithms, everything switches. So for exponentials, the domain was all reals. What do you think is going to be all reals when we do logarithms?
Range.
Range. Yep, everything switches. So the range is all real numbers. And for an exponential, the domain was 0. I'm sorry, the range was 0 to infinity. Well, for a logarithm, that switches. So if you take the domain and range for exponentials and just switch them, now you have them for logs. Okay, any questions on that?
Sorry.
Okay, so if you can't remember both of them, then don't. Just remember exponentials and say, all right, he said switch them when you do logs. Switch them. So the domain used to be all real numbers. Now the range is all real numbers. So it makes it easy to kind of remember. Okay, question on that? All right. So what we want to be able to do, this will be probably the last thing that we get to, is to change between what's called log form and exponential form. Let me show you a couple problems so you can kind of see what I'm talking about. That is log form. We know something is log form when it has the word log in it. That's also log form. That's exponential form. Exponential form is when you don't have the word log and you have a base, an exponent, and something on the other side. Okay, so that would be called exponential. That's exponential. That is also exponential.
Sorry.
That's log form. Okay, so we're going to learn how do you change between the two. And then I think probably example 4 or 5 is going to be a good place to stop. All right. So to change between the two forms, it's not really any math. It's more of just taking things and moving them around. When you have something in log form or exponential form, there's always 3 parts to it. There's the part that I have on the left here, there's the base, and then there's the argument. So we just have to kind of learn where those 3 things go, and I'm going to try to explain that right now. What do you call that number that's written a little bit lower than the word log?
The base.
That's called the base. When you rewrite something from log form to exponential form, that's the base. And what do you call the thing that's lower than the exponent? It's also called the base. So the base turns into the base. The base stays as the base when you rewrite. So that's where the first thing goes. Okay, the second thing is I'm going to write this down. Logs always equal exponents. Logarithms always equal the exponent. That's what a logarithm is. It's used to find an exponent. So in this case, the logarithm equals the exponent. Whatever the logarithm equals, that's the exponent. So in this case, it equals y. So y becomes the exponent. Okay, so remember that. Logarithms always equal exponents. And then the only thing that's left is this. What did I call that? I had a name for that. That was the thing you're taking the log of. Yep. That's called the argument. So x is called your argument. And what happens if you argue with someone all the time? Eventually, what's going to happen?
They'll give up.
You're going to give up, and what's going to happen to you?
No, I won't give up. They'll give up.
Kick you out.
Yeah, they're going to kick you out. You're going to end up by yourself. So the argument ends up by itself on the other side. The argument ends up all alone because it argued with people, so it's all by itself. So changing between log form and exponential form, there's no math involved. It's just taking things and rearranging them. Next, we'll try a few of those and how to solve a few equations doing that, and then I think that'll be a good place to stop. Let's look at that one. Well, they're telling you to change it to an exponential expression. That means when you're done, it's going to look like this. You're going to have a base, you're going to have an exponent, and then something by itself on the other side. Okay, let's start with the base. What's the base here? Yeah, 3. 3 is the base. Logarithms always equal what kind of number? Exponent. Logarithms always equal the exponent. So y is the exponent. And what ends up by itself on the other side? The x, because it's the argument. It argued with everybody. It ends up by itself. Now, there's nothing more you can solve there. If you knew y was like 2, well, then you could plug in 3 to the second power and get 9. But there's nothing else we can do. That's it. That's how you change from log form to exponential form. Let's try now. Right. Start with your base. What's the base here? 5. Logarithm always equals what kind of number? The exponent. So in this case, the y is the exponent. And what ends up on the other side by itself? The argument. And in this case, the argument is x. Again, there's nothing more that you can do with that because you don't know what y is. Question on that? Let's try it the other way. Now, they're giving you something that's already in exponential form, and we want to change it to log form. Well, what do you think the first thing you have to do, or what do you think the first thing is you have to write down if you're going to write something in log form? You need the word log. Yep. And let's do it just like we did before. Start with the base. What's the base in 1.2 to the third power equals m? 1.2. 1.2. So that's your base. Logarithm always equals what kind of number? The exponent. What was the exponent?
3.
3. And the thing that was all by itself is called the argument. And there's only one place left for it to go. And that's how you change an exponential to a log. Why you would do this is when you're solving an equation. Sometimes you need to change from one to the other. All right, let's do this one. Change it to log. What's the first thing we should write down?
Log.
Write down the word log. Okay. What's your base going to be? E. E. Logarithm always equals what kind of number? Exponent. And what's my exponent in this case?
B.
B. And the only thing I have left is the 9. And what's that called? The argument. That's the argument. Now, we talked about writing log base E. That's what we did is correct. What's the abbreviation that you usually see?
LN.
LN. And that is something you could type in on the calculator. That's not the question here. They don't want to know exactly what the ln of 9 is. But if you type it in, it's about 2.197. Okay, how about this one? First thing we'd write down? Log. What's your base?
A.
A. Logarithm equals the exponent. What's your exponent?
4.
And what is your argument?
24.
Yeah. Now, there's nothing you can do to solve that one because you know, there's nothing else we can do. So we just leave it like that. Any question on it? Let's try this one. It says to show that log base 2 of 8 equals 3. Well, what kind of equation is that? Is that log form or is that exponential form?
It's log form.
It's log form, yeah. So let's rewrite it in exponential form and see what happens. So remember, exponential form looks like this. What's the base? 2. Logarithm always equals what kind of number? Your exponent. And what ends up by itself on the other side? The argument, which in this case is 8. So that's how you rewrite it into exponential. Now simplify. What's 2 cubed?
8.
And is that true?
Yep.
Yeah. Then we just showed that log base 2 of 8 equals 3. That's all I had to do. Any question on it? Alright, let's try this one. Just using the same, we're just going to practice that one thing today. That's all we're going to do. What type of equation is that? Is that a log or an exponential? Log. The only trick I've given you so far is to change it to the other one. Whatever one it is, change it to the other one and see what happens. What is your base here? And logarithm always equals what kind of thing? Always equals the exponent. And what's going to end up by itself on the other side?
1/25.
1/25. Now, if you're stuck on that one, think of this problem instead. It's not the same answer, but 5 to what power would give you 25?
5.
Oh wait, no.
2. So 5 to the second would give you 25. What kind of number does the exponent have to be to flip the 25 and give you 1 over? Negative. So what do you think x is?
Negative 2.
Yeah. So if you get stuck on a problem that has a fraction, just remember, okay, when it has a fraction, it's supposed to be a negative, and think of what the answer would be if it wasn't a fraction, and then just make that number a negative. Any question on that? Yeah, we're not doing probabilities today. So let's do these last two. It's the same thing that we did. Same thing again. Is that log or exponential? Or log. Can anybody tell me how you'd rewrite it as an exponential? Yep.
5.
5 is the base. Yep.
Exponent of 1.5
Exponent of 1.5.
equals x.
Yeah, that easy. Now you just type in 5 raised to the 1.5. So it's about 11.18. As long as you know that trick of changing it from log form to exponential, it makes it pretty easy. Let's try. Did everyone have that one? Before we do the last one? Okay. Because I can't keep them both on the screen, I don't think. So this one had the variable in the argument. This one has it in the base. Same approach. A little different way we have to solve it once we change it. How would you rewrite that one? Yeah?
Would it be x with an exponent of 2 equals 3?
Yep. X with an exponent of 2 equals 3. And now, how do you get rid of that exponent of 2? You square root it. And I know normally I always tell you, when you square root, you get 2 answers. You never have to worry about the negative answers. Logarithms cannot be negative numbers. If you try to take the log of a negative number, look what happens. It says non-real answer, which would mean it's what?
Imaginary.
It's imaginary. So we're not going to do negatives. So the answer is just the square root. That's the first part of logs. Just a little practice changing between log and exponential, and that's where we'll stop.
So you only do that if the base is x?
You only do what if the base is x?
Yeah, the square root.
Well, we took a square root because we wanted to get rid of the square. I mean, if you ended up with like x cubed equals something, then you take a cube root of each side. So you got to take basically whatever root that number is. If it's a 5, you're going to end up taking a 5th root. Yeah. Does that answer your question?
Yeah.
Okay.
I'm guessing math went too simple, so it could just be 110 there. You just take the 110th root.
Yeah, we won't ever have one that big.
Ah.
Yeah. Let me put that. Don't write that yet. Let me. So the homework is on page 292, numbers 1 through 6.